Concave lenses are used to form images on the same side of the lens. Now, lenses are devices which use specially shaped glass to refract light and form an image. For example, a concave lens will cause parallel light rays to refract and diverge, but appear to converge at a point before the lens. When thinking about how a lens forms an image, we should always draw in the principal axis of the lens. This is a straight line through the middle of the lens. Any ray travelling along this line will not refract in it. Let's suppose we have an object on one side of the lens. At GCSE, it will be assumed that this is standing on the principal axis and extends upwards for simplicity. In real life, though, it would probably be around here, so that the principal axis cuts through it. Then, because of how light is refracting through the lens, an image of the object would be seen here. This is because if we were to look through the lens from the other side, then our brains would be tricked into thinking that light reflecting from the object originates from where the image is rather than the object. We can refer to this as a virtual image, but we'll see what that means elsewhere. For now, let's focus on how we determine where this image would form. Ray diagrams are used to determine how the light rays from an object pass through a lens and diverge to form a virtual image. Often, in an exam question, the lens and its principal axis will already be drawn for you. Here, this symbol has been used in place of a concave lens to make the diagram neater. You need to be able to recognise what this symbol means and not mistake it for a convex lens. Remember that the arrowheads here show how the lens is curving inwards at the top and bottom, just like a concave lens. Let's now see how we would draw a ray diagram to show how this concave lens would form an image. In step 1, draw an arrow from the principal axis to represent the object. By drawing the object as an arrow, we neatly show the only important information we need for the ray diagram. That is its position on the principal axis and its height above it. Though this arrow may have already been drawn in for you in an exam question. In step 2, draw a ray from the top of the object through the centre of the lens. Because of how the lens is designed, any ray that is directed straight through its centre will refract in a way that doesn't affect its overall path. So we can draw a ray on our diagram like so, since we know that it won't change direction after passing through the lens. In step 3, mark the virtual focus of the lens. Remember that when we direct rays parallel to the principal axis, they will appear to converge at a point on the axis. This point is the virtual focus. In an exam, this position might be marked on the diagram already for you, or you may need to find it by measuring from the lens using a given focal length. In step 4, draw a ray parallel to the principal axis to the lens. So we draw a parallel ray like this. Because of how the lens works, it will be easy to predict how this ray will refract through it. In step 5, draw the refracted ray so that it passes through the focus when extended. Remember, this is how the virtual focus is defined. A ray parallel to the principal axis like this must appear to pass through the focus when extended back. So we draw in a refracted ray that appears to diverge from the first ray we drew on the diagram. But when drawing this diverging ray, we should line our ruler up with the focus. So now, if we follow the path of the ray back, we see it would pass through the focus. This dotted line of us tracing the ray back is the important thing to draw in this step. You don't have to draw it as a dotted line, but this helps show the examiner that you understand what is happening here and how the image forms. And finally, step 6, draw an arrow from the principal axis to where the rays converge to represent the image. If we were to look into the lens from the other side, our brains would think that these rays from the top of the object would actually originate from this point here. So this is the top of our image, which we label as a virtual image. For your exam, make sure you have a good understanding of this process, as you will likely be asked to draw a diagram like this for either a concave or a convex lens. Though many of the steps are similar, make sure you understand the differences between the two and don't get them mixed up.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!